lecture number 4, we're going to do 3 climates, and what they have in common is that they're all dominated by the continental effect on temperature. Now remember, in our previous lecture, we ran out of land in the southern hemisphere, and so all remaining climates, well, with the exception of Antarctica, all remaining climates are going to be found in the land hemisphere, the northern hemisphere, where the land is at their widest and the continental effect on temperature is going to dominate. So we're going to do the dry mid-latitude, and our representative location is in Colorado, right at the base of the Rocky Mountains, a town called Pueblo. Now you go just north of Pueblo, and you've got Colorado Springs and Denver you may be more familiar with. But all 3 of these cities are located right at the base of the Rocky Mountains. But anyways, the theme is that all of these 3 climates, and indeed this one, has a large annual temperature range. You know, Colorado, just think about its location in the interior of the United States. It's going to have hot summers and cold winters, so it's a pretty large annual temperature range. Now the thing is too, this is a dry climate. Right? The precipitation is really, really low, and we're going to be looking at our drier desert climate map again. Now here in Colorado, and in this climate in Asia, we're in the mid-latitude location, so it's immediately telling you that it's going to be dominated by wave cyclones all year long, But the thing is that these fronts in the wave cyclones aren't really producing much precipitation at all. I mean, they're kind of dry, low moisture fronts. And the reason is that this climate is only found in the interior of continents in the northern hemisphere, where the continents are at their widest. Now let's show you the 2 continents and where this climate is located. All right, in North America, in the United States, the major world location, here's climate number 9. This is the Great Plains. All right, that is really the major world location. And remember, this is a dry climate. And so you had the dry tropical, dry subtropical, and now it's mid-latitude. And so they kind of stack right on up. Now, in the United States, why the fronts are dry, if you think about them, they're coming in off the Pacific Ocean in the westerly winds. And what we have in the western U.S. are a series of very tall north to south trending mountain ranges. And they're affected by the orographic precipitation and the rain shadow effect, orographic and then rain shadow. And by the time those wave cyclones track across the final big tall mountain range, the Rockies, those fronts have dried right on out. Now the thing about the fronts though is now they pick up moisture. They continue tracking in the westerly winds, and after they're pretty dry for the western half of the U.S., they pick up Gulf moisture and become moist again, and pretty good rain producers. Now in Central Asia, here's number 9 right in through here. It's the Central Asian deserts, and here's a nice example. Afghanistan would be a good example. Kind of the same thing. We're located in the interior of a very large continent, and the Atlantic fronts, as they track thousands of miles across Eurasia, just simply dry out, and we have low moisture and dry fronts. So what we want to do is plot this on the hypothetical continent, mid-latitude location in the interior of continents. And so we're going to be dominated by the westerly winds and wave cyclones, but they're dry, either due to the rain shadow effect or just simply too far from a moisture source. Climate number 10 is the classic continental climate. Remember, we're looking at the name, so it's going to be a rainy climate. It's moist, but continental in the name is telling you it's going to be representing the continental effect at its greatest. So we really do have a very large annual temperature range for our climate graph here in Wisconsin. And very large. Every 6 months, 50 or 60 degree range in temperature between summer and winter time. And again, take a look at where we are in Wisconsin. The land is heating and cooling very, very dramatically. And now this climate is wet all year. What winds up happening as we move eastward now, we start to pick up Gulf moisture and the fronts become wet again. And it's not showing you the icon of the wave cyclones, but it is wave cyclones all year long, producing ample precipitation for this climate. Now, the thing about wave cyclones, if you remember when we did that, you wind up with a highly variable weather. It's kind of like a roller coaster ride of weather. Just think about what we experience in winter time here when we're dominated by wave cyclones or fronts. Well, this climate has it all year long, all right? Not just winter, but spring, summer, fall. And you wind up with really highly variable weather. And if you really kind of take a look at, I've got this map here showing the tracks of all the lows, or where the origin of the wave cyclones in North America. Take a look where they're tracking in the westerly winds, crossed the continent of North America, and look at where they all wind up focusing in the end. They all track to the northeast, north central U.S. And so it's front after front after front, changing the weather. And I grew up here in upstate New York, and there was kind of a joke that they say about how variable the weather is. They say, the joke is, if you don't like the weather, wait a minute. So that's how variable it is all year long. So let's kind of track it. Let's see, major world locations on the two northern hemisphere continents, kind of north central, northeast U.S. In the westerly winds, the continent is really going to dominate temperatures, heating and cooling. Now, you're also going to find this in Eurasia, in the interior a bit, in Poland, Germany, into Russia. Then another major world location is northeast China. Remember, China's a big, big country. And in southeastern China, it has our climate, the moist subtropical. And then to the northeast, you're going to find the moist continental. Right. And so Beijing, the capital, is located about right here. And so Beijing has kind of a cold, snowy climate, kind of similar to, what you would find in maybe Chicago or New York City or something like that. So we want to plot it on our hypothetical continent, mid-latitude location, the moist continental, and you're pretty much going to find it north of the moist subtropical, and in two major world locations in North America and Asia. All right, climate number 11, all right, is called the boreal forest climate, and boreal means northern. Right, so this is a northern climate, and it's named after the type of forest that you find at high latitude locations. The boreal forest is kind of a cold needle leaf evergreen forest. So boreal means northern, and the important thing about the boreal forest climate, this is it. This one has the largest annual temperature range of them all. So that's kind of what we've been talking about, but this one is the biggest, all right, for two reasons. The first reason is that we're really at a very high latitude location. We've got two weather stations plotted here, one up in Alberta, Canada, and one in Russia. So very high latitude. Now, particularly in wintertime, all right, sun angles are very, very low, and periods of daylight are quite short. And so winter temperatures are really cold, really, really cold. And so you wind up pulling down and kind of stretching out our annual temperature range. Then on top of the high latitude location, we are where the continental effect is going to be at its largest. The continents are at their widest at this high latitude location. So now add the continental effect in wintertime on top of the large annual temperature range due to the continental effect, and the continents are frigid, and again pulling on down that annual temperature range. Now the precipitation is low. It's going to be due to fronts or wave cyclones. If you kind of think, what is going to be the major mechanism, the only rain producer is wave cyclones in this latitude range, so kind of high latitude location too. But the fronts are dry. Now in this case, they're dry because of the cold, particularly in wintertime. When you've got temperatures well below zero, that cold air cannot hold much moisture at all. So you kind of take a look at the precipitation during the cold winter months. That's where it's at its lowest, where the cold air really, cannot hold much moisture. And then once it gets a little bit warmer in summertime, warm air can hold more moisture. And that's when you're going to have kind of the precipitation peak during the warmer summer months from these wave cyclones. So on our world map for North America, you're going to find this climate at very high latitude locations in Alaska, and of course Canada is kind of, what I usually think of. And then the other major world location in Eurasia, kind of Northern Europe and Russia and Siberia. It's pretty classic. So what we want to do is plot this at kind of a high latitude location. We're going to go to, be above the Arctic Circle in this case, and we'll plot the boreal forest climate, and still influenced by wave cyclones, but it's where the continents are at their widest. That's kind of what we also want to show. End lecture.